Hello guys, welcome back to Maison African Motives. Still on mathematics grade 11, working on analytical geometry. We have got the question from the question paper of November 2017, paper 2, that is DBE November 2017, where we are given question number 3. So we've got the point A, which is given as -2, -5. That's our point A. The point B, the point C, and the point D are vertices of quadrilateral A, B, C, D. All right. So this is the quadrilateral that we are given. And also on this quadrilateral, we are given that such that AC, that is the diagonal AC, is perpendicular to diagonal BD. So you've got from A to C and from B to D, these two diagonals, they are at 90 degrees perpendicular. Thus, they are at 90 degrees. This is 90, this is 90. Either way, that you're going to have, that will be 90, 90. That is what they are trying to say. And we are given the equation of B, TD is given by, that is the line from B here to T and to D. We are given the equation of this line, that is 2y plus x, which is equal to 18, and also AB, which is 15 units from point A up to point B. This distance we are given as 15 units. All right, so let's see what you're given in this case. 3.1, determine the gradient of the line AC. All right, so in this case, that's 2 marks for that. So remember that the gradient, we can simply take this from the change in y over the change in x. All right, so let's see where we've got our A and C in this case. If you are to check here, we have got our point A and our point C, where we do not have this coordinate at point C. So meaning to say, we can't use this concept of determining the gradient. We were supposed to have our gradient like this. That was actually supposed to be the actual way. The gradient of AC was supposed to be taken from the change in y over the change in x, y2 minus y1 over x2 minus x1. But we do not have the corresponding point, which means this formula is invalid for now. So what can we do? Let's get back to this condition that we are given, that these two, they are perpendicular. All right, AC is perpendicular to BD. That is this part here. From A to C and from B to D, these two, they are perpendicular. So this can give us something. If these two are perpendicular, so let me just write this part. AC is perpendicular to BD. So if these two are perpendicular, what does it mean if these two lines are perpendicular? It means that the product of their gradients, that is the product of the gradient of line AC and the line BD, the gradient of line BD, is going to give us a -1, the product of the gradients. So this part, we are still limited somehow, because so far we do not know the gradient of the line BD. We want to calculate the gradient of AC. We do not have the gradient of BD, but we can take advantage from the line BD. We have got the equation of this line. So we know that if we are given the equation of a straight line, we can determine its gradient. That's 2y plus x, which is equal to 18. If we can have our equation in the form of y is equal to mx plus c, we know that this m is going to represent the gradient in this case. So how can we do that? We have to make y the subject. So you can transpose x to the left-hand side so that it can be a -x plus 18. So to find y, as y is equal to, so you have to divide by 2 each and every term. So that's y is equal to, this is same as -1 over 2x. So we can write this as -1 over 2x, 2 into 18, which is going to be a 9 if you divide 18 divided by 2. So this is our mx, the part that is multiplying x. X is multiplied by a half. So that means from the line BD that we are given in this case, from the line BD that we are given, we are having the gradient in this case. So the gradient of line BD is -1/2. So this is the one that we are going to use now to determine the gradient of AC, because we are saying the product of these two should give us a -1. So that's here we can substitute the gradient that we got, which is 1/2, into this formula. That's the gradient of AC times the gradient of BD, which is the gradient of BD is minus a half. So that's minus a half is equal to -1. So in order for us to have the gradient of AC, we can simply divide by -half both sides by -half both sides. So this can cancel. We remain with the gradient of AC. So that is -1 divided by -2, which is going to give us a +2. So the gradient of line AC is a +2 in this case. All right, so this is what you're going to have. Then from 3.2, now we are given to determine the equation of AC in the form of y is equal to mx plus c, and that is 2 marks for that. All right, so take note here, we have got the point that lies on AC. We calculated the gradient of AC, and there is a point that is lying on AC here, which is the point A. So we have the gradient and we've got the point A. So we can be able to determine the equation in this case. All right, so let me just have it here, 3.2. So we need the equation of line AC in the form of y is equal to mx plus c. So from this part, we are saying that we have got the gradient of line AC already. We calculated the gradient of AC, which is 2, which is 2 in this case. So the gradient of AC is given as 2. And there is a point which lies on this line, which is the point A. This point A, -2, -5. So at this point, we can be able to calculate our equation. All right, so the point A is -2, -5. So that means using any formula that you want to apply, so you can just substitute on this format that you're given, because M represents the gradient. This M here is your gradient, and our gradient is 2. So that means y is equal to 2x plus c. So to find the c, you simply substitute this point. That's your x and that's your y. So in place of y here, you are going to substitute this y that we are given, which is -5, which is equal to 2 times x. So you open a bracket to multiply your x from the point, which is -2. Simply like that, you can find the value of c. So you substitute the point that lies on the line that you are calculating the equation. If we had the point C, we can also use the point C, but we do not have the point C. That's why we opt point A. All right, so this is going to be -5 is equal to 2 times -2. That's -4 plus C. So we can transpose the -4 to the other part of the equation so that it can be a positive. So that's -5 plus 4 is equal to C, where C is going to be a -1 in this case. That's -1 is equal to C. So that means C is equal to -1. So if C is equal to -1, that means we can substitute this part. All right, so we can gonna substitute our C here. This is our point C, I mean the value for C. So we can substitute back on this part where we are given y is equal to 2x plus c. What we wanted there was to calculate the value for c. So we now have the value for c. So therefore, our equation is going to be y is equal to 2x. So that's 2x plus c. So that's plus a -1, and a negative and a positive gives us a positive. So this is going to be y is equal to 2x minus 1. All right. So that is how we can actually determine. But remember that this is not the only option for us to have the equation of a straight line. The equation of a straight line is also taken from this format of y minus y1 is equal to m into x minus x1, where y1 and x1 is taken from the point that we are given that we were using as x and y before. So this time I'm just going to write this as x1, y1. So we are going to substitute everything into the formula y minus y1, which is a -5. So that's a negative, and a negative gives us a positive, which is equal to m, which is our gradient of AC. So m is equal to 2 in this case. So that's x minus x1 in this case. All right. So our minus and the minus, again, this is going to be a positive, negative, negative. So that will be a +2 in this case. Okay. So after you have substituted this, you can expand the brackets from the right-hand side. So that means y plus 5 is equal to 2 by x. That's 2x, 2 and 2. That is going to be a 4 if you multiply. So you can transpose 5 to the other side of the equation so that it can be a -5 in this case. All right. So that is what you're going to have. So meaning to say that here y is equal to 2x plus 4. So if we transpose the 5, it is going to be a negative 5. So that means y is equal to 2x. 4 minus 5, that is a negative 1. So as you can see, we are simply having the same thing as the first part. This one, y is equal to 2x minus 1. Still, we are having the same answer, y is equal to 2x minus 1. So you can use any part or any presentation to obtain your equation. But what is important is your final answer. You must have it in the form of y is equal to mx plus c in the gradient intercept form. All right, so that was our question. In this case, we move on to the other part of the question. We are now asked if the equation of AC we are given that we take note, guys, what is happening here. You were asked to calculate the equation of AC. And now they are giving you to say if this equation of AC is 2x minus 1, which is the one that we got. So this, it must be a wake-up call for you to say you calculated the equation of AC and you got another answer which is actually different from this. Redo the question that you're given and try by all means to obtain the, because you are having the answer already. All right. Anyways, that is not part of the question. Here we are asked to calculate the coordinates of t. All right. So we are given the equation of which we calculated this equation before. Where is the point t? We have to note where our point t is. All right. So take note. Our point t is the point which lies at the intersection. That is the intersection of the diagonals BD and AC. So AC is the one that we are given its equation, the one that we calculated, and we got y is equal to 2x minus 1. So what is it about the point T and these two lines? The point T is the point of intersection. So at the point of intersection, the two lines, they are equal. Line B, BD and line AC will be equal at the point of intersection. So let me just write this or present this here. So what I'm saying is that at the point of intersection, so T is actually the point of intersection. So this is our point of intersection. And we are saying that at the point of intersection, the two graphs are equal. So at the point of intersection, that's the point of intersection. In this case, the two graphs are equal. The two graphs are equal. So this is what you're supposed to note. So meaning to say, we have got two lines that we have the line of BD and the line of AC. From AC, we got y is equal to 2x minus 1. So that's our equation. So from line AC, our equation is from line AC, our equation is y is equal to 2x minus 1. Then we talk about the line BD where we are given our equation. But remember, we wrote the equation of BD in the y in the intercept form, the gradient intercept form here. This was our line BD. If you take note, this is okay, up to this part here. This is up to this part where we wrote our equation as minus 2x plus 9. This is the equation of line BD, just in the form of the gradient intercept form, that is y is equal to mx plus. So this is the one that I'm going to use here. Y is equal to minus half x plus 9. So from the line BD, we have the equation that corresponds there. That is y is equal to negative half x plus 9. Okay, so we are saying that at the point of intersection, these two, they will be equal. That is the AC and the BD. They are equal in value. This y value, the y value. So meaning to say this part of x also is equal at the point of intersection. So this can be an advantage. So we are simply going to equate the right-hand side because we have written in terms of y. So these two, they are equal also. So that means 2x minus 1 is actually equal to minus half x plus 9. So by this, we can be able to calculate the value of x. All right, so by calculating x, we can transpose to any negative half to this side so that it can be a positive. So that means we are going to remain with the 2x plus half x, which is equal to, if we transpose negative 1 to this side of the equation, the right-hand side, it is going to be a positive. So this is going to be 9 plus 1, which is a 10 in this case. Okay, so let us add and see what you're going to have from the left-hand side. 2x plus half x. This is 2 plus half from your calculator. 2 plus a half, that is 5 over 2x, which is equal to 10. Or this can be 2,5 or 5 over 2. So you can divide by 2,5 or by 5 over 2 both sides, so that we can obtain the value of x since we are multiplying. So x is going to be equal to 4 if we simplify properly. But remember what I was saying, that at the point of intersection, these two graphs, they are equal. So in order for you to obtain the value of y from this x, you're going to substitute into any of these two equations. You can substitute here or you can substitute here. You are going to obtain the same value of y. So let's say we decide to choose this first part of AC. Y is going to be 2 times x. Our x, which is 4, so that is 2 times 4 minus 1. So you can obtain the value of y from them, which is going to be 7, which was the same thing also if we substituted into the equation of BD, where y is equal to minus half x, and our x is equivalent to 4 plus 9. So this is going to give us the same value of y, which is a 7. This is going to be negative 2 plus 9, which is a positive 7. So thus, therefore, the point T that we are talking about, which is the point of intersection, is now made by the 2 points. So therefore, our point T is going to be made by the 2 points, the x value and the y value, our x value here, which is a 4, and the y value, which is a 7. From either equation, we are going to obtain y being a 7 in that case. Okay, so this is how we can actually find the point of intersection. You solve the given equations simultaneously. That is what you are simply saying. You simply solve the given equations simultaneously at the point of intersection. All right, so let's check the other part of the question. That is on question 3.4. We are now given that if this quadrilateral that we are talking about is a kite, that is A, B, C, D, the quadrilateral that we are having is a kite, and we are given that AB is equal to BC. 3.41, we are now given to determine the coordinate of C. And that is 2 marks for that. Okay, so let's start by having this as a kite, A, B, C, D. Okay, so if this is a kite, what are the characteristics or what are the properties that we know about a kite? We know that these two corresponding adjacent sides will be equal. This BC and this AB, they will be equal in length. Also, from A to D, this part is going to be equal from C to D. So these two, they will be equal. Okay, so here we are given this condition, but we are supposed to know, there they stated that AB is equal to BC, which is this condition that we see here, AB being equal to BC. So what can we do with this information to determine the coordinate of the point C? What can we do in this case? Okay, this part I want you to take note, okay? Or let me just erase some of this information. Let me just remove so that we do not confuse each other. Remember, we have these values. Okay, so I was saying here, this point from A to B and this line from B to C, they are equal. And also from B to D, from A to D and B to C. Okay, this is not the matter of fact for now. What is mattering is that if these two are equal, we are going to see that from A to B to C, the triangle that is formulated is going to be an isosceles triangle, but it's like this. So remember that these two sides are equal. These two sides, this is B, this is our A, and this is our C. So these two sides are equal. So what does it mean? It means that the line that is drawn, this B, T to D, this line that is drawn, our diagonal, it's actually bisecting the line AC. This is a line of symmetry on an isosceles triangle. So it bisects the line AC. So if it bisects, to bisect is to divide into two equal parts, meaning to say from A to this point T here is the same as from the point T to C. We have got same distance from A to T. It is the same as from T to C. So what does it mean if these two are equal? It means T is the midpoint. So this point T that we see, because here we've got same distance from this point to T, and from T to C, we've got same distance. So it means literally this point T is the midpoint. So T is representing the midpoint. The midpoint of what? The midpoint of line AC. So this is the midpoint of line AC. So if T is the midpoint of line AC, how can we determine now the point, the point C? Remember, before we calculated this point T, we calculated our point T before we got 4, 7. If you still remember from that calculation that we made from calculating from the equations, we had the point T. So now we want to calculate the point C, which we do not know in this case. Let's just say XY. So this is leading us back to the midpoint concept to say, how did we calculate the, because we are saying T is the midpoint. Before, how did we calculate the midpoint? In this case, how do you calculate the midpoint? That's how you simply ask yourself. So it means that T was simply taken from x1 plus x2 over 2. That is y1 plus y2 over 2. This is how you calculate the midpoint. So this part corresponds with our point T, where we have got 4 and 7. So it means that if I add the x here on point A, which is minus 2, plus the x at point C, which is a x, over 2, this is going to give us the exact point that is at T, which is our midpoint. So our T at midpoint, the x is 4. So this is equal to 4. We have formulated an equation from there. The same thing is going to happen for the y values, y1 plus y2 over 2, meaning to say, if we add this y value at A, which is minus 5, plus the y value at C, which is y, in this case, we do not know this value, over 2, we are going to obtain the y value at the midpoint, that is at point T, which is a 7, like this. So this gives us two equations that we are supposed to solve for x and y. By solving for x and y, we are actually finding the point C, because our point C is x and y. So how can we obtain the point x and the point y from this information? All right, so let me just push this aside so that we can have space to calculate here. So from the first equation, we can cross multiply. Okay, this is same as over 1, so we can cross multiply here. That is 1 is going to multiply everything on top. So that is 1 times minus 2. That's minus 2. 1 times x, which is x. On the same part, that is 2 times 4, which is going to be 8. So here we can find x by transposing negative 2 to this side so that it can be a positive. So that is our positive 2 on the other side. So 8 plus 2, that is going to be 10. So the value of x is going to be 10. Okay, on the other hand, we can solve from the y here. We can solve also same as over 1. So you can cross multiply just like the previous part. 1 times negative 5, that's negative 5. Okay, so let me just try to separate so that we do not confuse each other. 1 times negative 5, we say that's negative 5 plus 1 times y, which is y, is equal to, if we cross multiply here 2 and 7, this is going to give us a 14. So we can transpose negative 5 to this side so that it can be a positive 5. So that means y is equal to 14 plus 5, which is 19. So the value of x, like I was saying, the value of x here and the value of y here are actually the point C is our C is xy. So that means therefore our point C from these 2 points, therefore our point C is going to be x, which is 10, and y, which is 19. So we have the point C from this information. So this is how we can actually apply the concept of an isosceles triangle in this case from the kite that we are given, but we have an isosceles triangle, so you can actually use this concept. Okay, then on the other part, now we are given to calculate the length of BT, 4 marks for that. Okay, where can we obtain BT from? BT. Okay, so this is what we have 4 marks for the 3 that is 3.42, this part here, the length of BT, and this is 4 marks. Okay, let's check from our diagram what we have. This is BT. All right, this is what we have from the point B to the point T. Remember that before we are told here that BA is actually 15 units here. We are given BA, which is 15 units, okay? So if we are to consider the 15 units that we have, we can, okay, let me show you the part that you are asked here. This is 3.42. Remember, we want BT, so let me just show you from B to T. All right, like this. Then, okay, so this is the line that you're supposed to calculate. Now, if we are to consider from this side, we have the same thing. Remember, we calculated the point C. We got our point C, and we know that from B to C, this is 15 units also. This is point we have. So meaning to say, this triangle here, that is BTA, is the same as the triangle BT to C. So you can choose to work with the first triangle that is from B to T to the point A, like this. This is the triangle that I'm going to use. And this triangle, it's a right angle triangle. Take note here, there's a 90 degrees. So this is a right angle triangle. So meaning to say, we can be able to calculate BT if we have got this length, because we have got BA. So we can calculate the length AT and apply Pythagoras theorem because it's a right angle triangle. So you can calculate from A to T. Remember, we have got the point A, we have got the point T. So let's calculate AT. So the length of AT from our distance formula is going, or length formula, is x2 minus x1 squared plus y2 minus y1 squared. So this here, thus we can just say x1, y1, and this is our x2, y2. So this means our AT is going to be the square root of x2 minus x1. That's x2 4 minus minus 2. So there's a negative 2 here. So it's going to be 4 minus 2 squared. All right. So this you can just put a bracket plus y2 minus y1. So y2 here is 7. Y1 is negative 5. So this is going to be 7 minus 5 like this, and everything squared. All right, so this is going to give us 80. So if you calculate properly, your 80, the first part here is the same. Remember, minus and minus a plus. So this is same as 6 squared plus negative, that's a positive, which is same as 12 squared. All right, so the square root of 6 squared plus 12 squared is going to give us 6 square root of 5 in set form, that is units. All right, so this is our AT. Meaning to say, we have calculated this distance here from point A to point T. This is 6 square root of 5. So like I was saying, from our Pythagoras theorem, because we are given two sides, the 15 units and the 6 square root of 5 units, and we want to calculate BT, which is the third side. So we can apply the Pythagoras theorem, which states that the square A squared, that is A squared plus B squared, is equal to C squared, or C squared is equal to A squared plus B squared, in that manner. So here we can substitute our values. That is, our BT is the one that we have to calculate. So you can just write the smaller sides, that is AT and BT. So this is AT squared plus BT squared is equal to C squared, which is the hypotenuse, which is AB or BA. So this is AB squared. So as we are to calculate this part of BT, so we can substitute our values. AT, we have got our AT here, which is 6 root 5. So this is 6 square root of 5 squared plus BT. The BT is the one that we are calculating. Okay, BT here is the one that we are calculating, remember. So that's plus BT squared, which is equal to AB squared. AB is the hypotenuse, which is 15. So this is going to be 15 squared. So make sure that you apply or use your calculator properly in this case. All right, so here we are going to obtain, if you simplify, 6 square root of 5 squared. This is going to be 180 plus BT squared which is equal to 225. So you can transpose 180 to the other side so that it can be a negative this side. So here we are going to subtract in order for us to have BT. So that's BT squared is equal to 225 minus 180, which is 45. So that is to find BT square root both sides. BT is going to be the square root of 45, or you can simplify further from your calculator. This is going to be 3 square root of 5 units. All right, so we managed to calculate BT using the concept of Pythagoras. In this case, we applied the Pythagoras theorem in order for us to calculate BT. So sometimes it can be like that, where you have to apply another theorem to calculate the length. No, it's not about that you are limited only to the geometry part. Okay, sometimes there is other part that you can actually apply. All right, so that is our question in this case. We move on to the other part of the question, which is question 3.43. Okay, write down the length of the radius of the circle passing through the points B, C, and T. Okay, let's take note. We want to calculate the length of the radius, but this circle, it must pass through B to C and to T. Okay, let's take note from our diagram BCT. Okay, where do we have BCT? Let me just remove this part. Okay, remove this part. Okay, let me remove this part. Okay, this is our BCT, B to C to T. Okay. So if we are to draw a circle and it passes through these points, let me see if I'm going to win like this. It passes through B. Sorry for this circle, guys, but it's supposed to be something of this nature like this. Okay, so this circle is going to pass through the point B, the point T, and the point C. So if you are to take note here, there's something that is happening. They're saying we must calculate the radius of this circle. So if you are to note here, if a circle is drawn, like this condition that is happening, and we are having a line that is creating an angle of 90 degrees at the circumference of a circle, there is no other line that can. Remember, we say this is at 90 degrees. If you consider what we had, that these two, they are perpendicular. So if this is 90, it means also here we've got a 90. So there is no other way that we can have a 90 degrees at the circumference of a circle, if not taken from a diameter. It's only a diameter that subtends an angle of 90 degrees at the circumference of a circle. So it automatically tells us that the line BC, this one, it represents the diameter. There is no other way that we can have a 90 degree at the circumference of a circle. There's no other way. It's only from a diameter. Remember from our theorems that a diameter subtends an angle of 90 degrees at the circumference, or a diameter creates an angle of 90 degrees at the circumference. So it means that this BC that we see here is a diameter. So if BC is representing our diameter, what about the radius? The radius, remember, it's diameter over 2. So we can have our radius. So BC, where can we have the length of BC? Remember, before we say these two, they are equal from the kite concept. So if this is 15, we say this is 15. So meaning to say we have got the length of BC, that is 15. So our radius is going to be the BC, which is our diameter, which is 15 over 2. So our radius, that is going to be 7,5, or 15 over 2, or as a decimal, 7,5 units. So this is going to be the radius. So we took this from our Euclidean geometry, okay? The diameter subtends an angle of 90 degrees at the circumference. So this is the one that we are going to apply. Okay, so that was the last part of the question on calculating the radius that is going to pass through these points. That is 3.43, having a total of 2 marks. So everything from this question was actually out of 15. So these are the typical questions that you're supposed to work with or to understand from your revisions, because they might ask you anything that is similar to this. So what you need is to make sure that you read the information that you're given properly, read and understand the information that you're given, so that you can attempt any question that you are given. Okay, but for now, guys, that's it from Maison African Motives. Till we meet again.